Hello, I'm Jim with we develop electrical products. Today we're going to discuss the second project with the Arduino Uno. This project we're going to have an LED and a resistor and our Arduino Uno and some wires. We're going to use a special pin on our Arduino Uno, and it's called a pulse width modulated capable pin. It's on our digital output side. And you can tell it's pulse width modulated capable because it's any of the pins that have this little squiggle mark next to them. We chose pin 9 to be the pulse width modulated capable pin we're going to use in this project. And what you do is you connect up a wire from pin 9, the output, around to our breadboard, and connects into the breadboard, and then goes to a resistor. Now, if you've never used a breadboard before, the way these work is these in the center are all hooked up horizontally. There's wire in between all these holes horizontally, but they're not hooked vertically. Then there's a gap here with no connection between this set and this set. These side on this side are hooked up horizontal, but not vertical. These over here are hooked up vertical, but not horizontal. Same with these, vertical, but not horizontal. So we're going to run this output of 5 volts, or pulse width modulated. Sometimes it'll be 5, sometimes it'll be 0, sometimes it'll be a pulse changing in frequency. And it goes over to here, connects to resistor. Now why we have this resistor is we got to limit the current going to our LED. The LED doesn't like full current. You can burn it out. So we limit the current. And I'll show you how we come up with the value of that resistor to limit that current so we don't burn our LED out. The LED also has a polarity to it. The anode end, which is this leg here, the anode has to be connected up to the positive side, and the cathode has to be connected up to the negative side, or the 0 voltage side. How you know that, in our diodes in our fun pack, the leg that is long is the positive side, or the anode side. The one that is short is the cathode side, or the negative side. So the way it's hooked up, the 9 volts is connected to the top of our resistor. Resistor comes down, connects to the anode of our LED. The cathode of the LED comes around, connects to a wire, comes back up here, and then goes back to our ground, GND, ground, and our Arduino. So that's basically our hookup for this next project. Now, how we got the value of this resistor is by Ohm's law. I've got a representation of the schematic here. This 5 volts is representing what's coming out of the Arduino if it's at steady state. And so we're going to have 5 volts up at this side and 0 volts down here at this side. So there's going to be a voltage drop across this resistor and a voltage drop across this diode. Basically, the 5 volts has to drop between here and here. We're just going to use a typical forward voltage drop for a red LED, which is about 1.8 volts. So we're going to assume 1.8 volts is going to drop across this LED. So in order to figure out how much voltage is dropping across resistor 1, it's just going to be equal to the 5 volts minus the 1.8 volts, or 3.2 volts is what's going to drop across that resistor. Now, in order to find the resistance value, we got to use Ohm's law, which is equal to voltage is equal to the resistance times the current. So if you rearrange that equation a little bit, it means the resistance is going to be equal to the voltage divided by the current. So we're going to use a typical forward current through the red LED, because all that current is going to go through this circuit. There's no other place for it to shunt off and go. So all the current is going to go through the red LED and through the resistor. So the red LED typical forward current is going to be somewhere between 10 milliamps and 20 milliamps. If you go too low, you're not going to have that bright of an LED. If you go too high, you can damage the LED. So I'm just choosing something kind of in the middle, about 14 milliamps. So the resistor value of resistor 1, in order to limit that current to 14 milliamps, is going to be equal to 3.2 volts, the voltage drop across that resistor, divided by the current flow through it, which is about 14 milliamps, or 229 ohms. Now, we don't have a 229 ohm resistor in our fun pack, so I just chose a 220 ohm that is in the fun pack. Now, if you don't have an ohm meter, if you do have an ohm meter, I just urge you to measure the resistance of the resistors you have in your fun pack and find the 220 ohm. If you don't have an ohm meter, you can use the color codes that are on the resistor, and you're looking for a red, red, brown. You can ignore the gold, that's just the tolerance band. So just look for a resistor with a red, red, brown, and that's the 220 ohm resistor in your fun pack. And put that 220 ohm resistor in there, and then you'll limit the current through that diode so you don't burn it out. Yet it'll be plenty bright enough. So that's basically our circuit. Now what we need is we just need to program it. We're not going to do the programming ourselves. The programming script sketch is already done for us in the Arduino. Just go to File, Examples, and Basics, and Fade. And it'll open up another window with the Fade program. And again, anything with the backslash and the star in between those two is just comment. It's just something that the user can read. The computer is not going to see it as something it has to execute. So basically it's saying we're going to be using analog write function. And that analog write function uses the pulse width modulation. So you can use any pulse width modulated capable pin on the Arduino Uno with that analog write function. And again, those are any of these pins with the little squiggle next to them. So we have 6 of them to choose from. And the only thing you have to change for a value is when we define this integer LED number 9, that means number 9 pin is going to be called LED from now on in this program. So we would just change it to one of the other pulse width modulated capable pins and just connect up to that pin instead. And that's the only change we'd have to do in this program. And then we have to define a couple of other variables. Another integer, which is called brightness. It's going to start out with a value of 0. And it means that the brightness of the LED is going to start out at a 0 value. So it's going to be off. And then there's another integer we're defining, and it's going to be called fade amount. And that's going to be equal to 5. And so then we got this declaration down here of a setup, which is we're setting up our pins. And we got a pin mode, which is setting up the LED pin, that pin 9, to be an output. And then we have our loop. And this loop is just what keeps repeating over and over again until we hit the reset button or turn it off. So we're going to be doing an analog write to LED, which is pin 9. And we're going to, that analog write, we're going to be writing the brightness value. Initially, it's going to be 0. So we're going to be writing 0 to LED. Then we're going to drop down here. The next function we're going to do is we're going to make brightness which is brightness started out at 0, going to be equal to the brightness of 0 plus the fade amount of 5. So brightness now is going to be changed to 5. We're going to drop down here. We're going to ask a question. If the brightness is less than or equal to 0, then we do this down here. Or if the brightness is greater than or equal to 255, we go this down here as well. So if it's going to be equal to less than or equal to 0, then the fade amount becomes minus fade amount. And so then we go down and drop down here. If it the first time through is equal to 5, so or equal to 0, so it's not less than or it's equal to 5, so the fade amount stays the same, and we just delay for 30 milliseconds so you can see the effect. And then it jumps back up to the top here. And we do another analog write with a value of 5 this time. And it goes back down through here, keeps going through. It goes 5, 10, 15, 20. So the intensity is increasing. Then it gets down here, it gets to 255. It makes this a negative fade amount. So now we subtract 5. So the brightness now is 250, 245, 240, 235, 230. So now it's decreasing in value. And it just keeps repeating that over and over again. Up, down, with a delay of 30 milliseconds each time. So you can see the effect. So if we've got our circuit all hooked up, like we said back here, if it's all hooked up this way, and you're confident you're okay, then you plug in your circuit, and you come up here to upload, and it says compiling sketch down here in the bottom, uploading, done uploading, and everything looks like it went fine. So everything should have been fine. Now you should see the LED increasing in value or intensity and then decreasing in intensity. So this looks what it looks like when it's all programmed. The LED is getting brighter and then dimmer and brighter and dimmer. So the program worked and it's doing exactly what it was supposed to do. Now I will have down the links to the 2 previous videos that will show you how to download the software for the Uno, where to buy the Uno, and then the second video shows you where to buy the components for this project. And those 2 links will show you how to get everything set up. So if you like this video, please hit the like button and subscribe to my videos and hit the bell next to the subscribe button so you get notified on future videos. And I appreciate it, and have a good day.